Hello everyone. Today we are going to solve question number 560. Subarray sum equals k. Let's read the question. Given an array of integer nums and integer k, return the total number of subarrays whose sum equals k. Okay. A subarray is a contiguous non-empty sequence of elements within an array. Okay. In this video, I'm going to discuss 2 to 3 approaches to solve this question. Okay. So let's discuss what the question actually says. Basically, what you have to do is you have to generate multiple subarrays and then you have to calculate the sum of the elements inside those subarrays. If the sum is equal to k, then you have to increase the count and you have to count all similar subarrays which have sum equal to k. Okay, so basically find all the subarrays with sum equal to k. So in this brute force approach, what we're going to do is we will be having a baseline which will be O of n cube and we are going to optimize it to O of n square. Okay. Both of this variant will have O of one space complexity. What you have to do is first you have to pick an index I. Basically I started from here, start the subarray, then another index j to decide the end of the subarray. Then you have to calculate the sum of each of the subarray. Okay. And once you have calculated the sum, if the sum is equal to count, then you are going to increment the count, and in the end you have to return the count. Okay, so let's visualize how it's going to be. Initially you had k equal to 3. This is a array and the sum is going to be 1 in the beginning. Okay, now what you're going to do is you have to pick another ending for the subarray. So first subarray is this, the next subarray will be this one. Okay, the now sum is equal to 3 and sum is equal to k, so we're going to do a count plus plus, and then j is going to move again, and then we will having sum equal to 6. Okay, and there's no concept of like there can also be positive elements and negative elements inside the subarray. Okay, so we have to just keep going forward. Okay, same way we are going to this time start from 2. Now we are going to move ahead. So now sum is 2, next iteration sum will be 5, and then for last we are going to start from 3 and we are going to end at 3. So sum is equal to 3 and sum is equal to k, so we're going to do a count plus plus. Okay, and you can see each time we are calculating sum again and again. Okay, so you can see the optimization will be, rather than computing the subarray from I to j, we are going to just calculate the just calculate using j and then check condition there itself. Let me just start with the O of n cube version. What you have to do is first for int I equals 0, I less than n, I plus plus, and yeah, I had this utilities already here. Okay, then what you have to do is then for int j equals I, j less than n, j plus plus, int sum equals 0. Okay, we have the I for starting point, j for ending point, and current sum is 0. Now what you have to do is you have to use another loop. Int, let's say start with l is equal to I, l less than equal to j, l plus plus. Okay, we can not use k because k is already used here. Okay, sum plus equal to nums of k. Okay, now you have, after calculating the sum, you have to compare here. If sum equals k, oh sorry, I have to write l over here. Yeah, if sum equals k, then you're going to do a count plus plus. Okay, and in the end, after the whole nested loop section, we have to return count. That's it for this version. Okay, now let's run this. It's accepted. Let's submit. So you can see here there's a TLE, time limit exceed, over here. Obviously the values are big, and we are basically doing this question using of n cube time complexity. Okay, so what I was telling about optimization is, what you can do is, rather than recalculating every time, okay, I'm going to remove this part, and then I'm going to have a sum outside here. Okay, I'm going to have a sum here, and then what you have to do is, you have to just sum plus equal to nums of j. Okay, so basically what we are doing is, we are just summing up the values here and checking if sum is equal to k as soon as we uh, incremented or decremented the new values inside sum. Okay, so this is just of n square method, the brute force, where we have optimized this method from O of n cube to O of n square. Okay, and everything else remains same. Okay, so let's run this and let's submit this. So yeah, you have completed the question. Basically, all the test cases are accepted, but the runtime is very bad because we have solved it using of n square approach. Okay, but this is the best memory based approach because we are using of one space complexity. In the next two approaches, we are going to use of n space complexity. Okay, so this is complete. Now, what you have to do is, we have to discuss the prefix sum approach. Okay, so let's discuss first why we need a prefix sum. Okay, why we need a prefix sum is, the prefix sum is the sum of elements from 0 to I minus 1. Okay, so in brute force approach, what we are doing is, we are overlapping subarray were recomputed again and again for same sum. Okay, this time we are going to store them in this prefix sum array, and then we are going to look up the values of those prefix sum using of one time. Okay, so basically this is prefix sum naive approach. So this is basic prefix sum. Okay, so same constraints over here. The steps here will be, what you're going to do is, first we will build a vector with prefix sum. Okay, prefix sum, we have to build it like this. Okay, prefix of I plus 1 is equal to prefix of I plus nums of I. Okay, next what you have to do is, you have to pick a starting index, then pick an ending index, and then calculate if prefix of j plus 1 minus prefix of I equals k, then you are going to increase counter. Okay, why it's so specific, let's see here. The intuition behind these two values being, the prefix of j plus 1 will be sum from 0 to j. Okay, prefix j plus 1 will be 0 to j, and prefix sum of I will be sum from 0 to I minus 1. Okay, so if we subtracted 0 to j minus 0 to I minus 1, okay, this one, 0 to j minus 0 to I minus 1, we got the prefix sum of the subarray from I to j. Okay, so we got the sum from I to j using these two prefix sum. Okay, so this is the main intuition behind using this specific formula. Okay, so let me help you visualize this. First, from nums, you're going to generate this prefix sum array. Okay, now what you have to do is, as we will start from this section, the starting part of prefix sum, then we are going to calculate this. The prefix of j plus 1 minus prefix of I. So prefix of j plus 1 will be 1 and prefix of I will be 0. So 1 minus 0 equals 1. Okay. Same way we are going to calculate for all the elements, the rest of the iteration. Okay. So let's see this one. You can see here the prefix of j is here, so prefix of j plus 1 will be 3 and prefix of I is 0. So 3 minus 0 is equal to 3, and since our k value is also 3, hence here we have to do a count plus plus. So basically we found a subarray where the sum of values is 3. Okay, same way we are going to do for here. So 6 minus 0 is equal to 6. Next we are going to start from 1. Last time we start from 0. Again we are going to do same procedure over here. we are we are not finding the correct answers over here, so let's say here 2 minus 1, it should be 1, sorry, it should be 1. Then here you got 6 minus 1 is equal to 5. Here you can see the next one. This is our final one. What we found is a prefix of j plus 1 will be 6 and prefix of I is 3. So 6 minus 3 is equal to 3, and since it's equal to k, we have to do a count plus plus, and in the end we are going to return 2. Okay, so this is the main intuition behind using prefix sum, because this way you're able to find the subarrays in between. Okay, so let's code this one. Obviously it also has a nested loop, so the time complexity will be O of n square and the space is O of n to store prefix sum. Okay, so let's code this. So here what you have to do is, okay, close this. Here what you have to do is, first thing you have to pick a starting index. So int I equals 0, I less than n, I plus plus. Next you have to pick an ending index. So for int j equals I, j less than n, j plus plus. You can match these two uh, nested loops using these two, as we always started from I equal to 0 and we reached I less than n. Same way, and since the prefix array is going to have a greater size, okay, we never built a prefix sum. Okay, sorry, my bad. So what you have to do is, first you have to build a prefix sum. So vector int prefix. Okay, so it will have a space of n plus 1 and it's going to store 0 in the beginning. Okay, now you have to build prefix sum. So as you can see here, to build prefix sum you have to use this formula. Prefix of I plus 1 is equal to prefix of I plus nums of I. Okay, so yes, we're going to start from int I equals 0, I less than n, I plus plus, prefix of I plus 1 is equal to prefix of I plus nums of I. Okay, so this way you're going to build the prefix array, and now we are going to iterate over uh, we are going to use nested loop to get a count. Okay, so here we have to write the same condition. If prefix of I, prefix of j plus 1 minus prefix of I equals k, then we have to do a count plus plus. Okay, so this was a base intuition to solve this question. Let's run this. So let's submit this one. Okay, yeah, we have done this question. This is also obviously an O of n square approach. Now the next one, what we're going to do is we are going to optimize this approach. Okay, we're going to use prefix sum, but this time we are not going to use a vector. In place of that, we are going to use a hash map. Okay, so let's see why we're using a hash map. So basically, a hash map, why are using hash map is, instead of generating all the I to j subarrays, we can directly know how many I exist. Okay, so basically every time what we were doing is uh, we are picking one I and then we are picking a j and then we are calculating the sum. Okay, this is redundant. What we have to do is we are trying to do this question in of n time complexity. Okay, so yes, this is possible. What you have to do is, firstly we have to use a hash map over here. Okay, so this is something a hash map looks like. Okay, uh, so basically same time complexity, and we are going to use hash map will we have of n time complexity, and space also will be of n, because we have to store a hash map. Okay, so what you have to do is, in this method you have to initialize map with mp of 0, then you have to maintain a running sum. Okay, for each sum you have to do these four steps. Okay, first step being sum plus equal to nums of I. So the new element that came, you have to add it. Then you have to calculate a requirement for the calculation. Okay, this required we'll discuss later. Then you have to increment the count using mp dot required, and then you have to increment the current sum of inside the map. Okay, and in the end you have to return the count. Okay, so the main observation being, in the last case we were doing a prefix of j minus prefix of I equals k. Okay, this was the last method's philosophy. This time we are going to find how many prefix of I we can find inside this hash map using this. Okay, so basically you have to find this prefix of I inside the hash map, and since the lookup of prefix lookup inside hash map is of 1, hence we are able to do this in of n time complexity. Okay, so rather than storing a vector, we are going to store a hash map. Okay, this way it's going to look, where first the key will be the prefix values that we calculated. Okay, 0, 1, 3, 6, and the count of number of prefixes of these numbers. Okay, so basically let's visualize this. So what you have to do is see this. Initially we had this array. We started from I, we had count some 0, count 0, and initially we have to fill this hash map with prefix 0 and count 1. Why? For sum 0, if we need a sum of 0, then we can always insert no value. If we didn't inserted any value, then obviously the count will be 0. Okay, next thing what you have to do is you have to iterate using this I. Okay, so I reached the first element here. I was like not calculated here. If we started calculation from here, so I reached the first element, sum is 1, count is obviously 0 because it's not equal to k. Now what you have to do is, we calculated the required, and we were finding the required. Okay, inside the map. So what you have to do is, the required current requirement is, since the sum is 1, the current requirement, if we had inside map as -2, then we can add the count of -2 here. But since we don't have -2 inside this hash map, so we cannot do anything over here. Okay, so count remains 0, and then we have, in the end we have to add the sum 1 over here and the count of it as 1. Same way we are going to next iteration. Here you can see the sum is 3. Since 1 plus 2 equals 3, now the count is 1. Why? Because we have to find the sum, we have to find this value inside hash map, value being sum minus k. So k is 3, sum is 3, sum minus k is equal to 0, and we know that we can find 0 inside prefix sum. Okay, so this is added here. Okay, next what you have to do is, you have to iterate for the next index. Here we have 3, so sum is now 6, and now you have to find sum minus k equals 3. Okay, and you can find sum minus k equal to 3 from here. So you have to subtract, you can just add the count of this number, the frequency, or basically count of frequency for the same thing here. You have to add it over this count. Okay, so this was all for this method. Let's try to code this one. Okay, basically you have to build a hash map, and you have to do these 4 steps. Okay, let's see what you have to do. First you have to build an unordered map, int comma int, and we can name it anything. I'm going to name it as frequency. Okay, now what you have to do is, uh, the first insertion inside this frequency of, okay, sorry, frequency of 0 will be 1. Why? Because if no values are picked, then the frequency will be 1. So basically prefix 0, the first element that we used to build over here, it's basically the same thing. Yeah, this one, we are building the same thing inside this hash map. Okay, next thing, what you have to do is, we are just going to need one iteration. So for int I equals 0, I less than n, I plus plus, and one more thing you have to do is, you have to initialize the sum equals 0. Okay. Now what you have to do is, we have to do these 4 steps. Okay, first thing being sum plus equal to nums. So sum plus equal nums of I. Okay, next thing what you have to do is, you have to find the remaining. Okay, so remaining is equal to sum minus k. Okay, remaining being sum minus k. Now what you have to do is, you have to increment the count of increment the count using the hash map lookup of required or remaining. Okay, so count plus equals to mp or baby frequency of remaining. Okay, and then in the end what you have to do is, you have to add the hash map lookup. Okay, so frequency of sum plus plus. Okay, so this is uh, the final algorithm to solve this question. Okay, this is basically, let's run this. Okay, we have to initialize the remaining. Okay, int remaining. Okay, yeah, it's accepted. Let's submit this. So yeah, we have solved this question basically using O of n time complexity. So you can see here, this is also the same thing. You have the current sum equal to k, then you're going to increase count, and if you have to find the same thing, you have to find remaining and you have to add it to the count. Okay, so this is also the same thing. I've also used the same thing. Okay. So that's it for today's video. Thank you.